Yes, Edwin. You got?
2-methyl.
You got 2-methyl.
3-ethyl.
3-ethyl.
Then butane.
Then butane. Okay, that is good. Then what team? This is
3-ethyl.
This is Edwin. 3-ethyl.
Ethyl. 2-methyl.
Then 2-methyl.
Butane.
2-methyl. Then butane. Okay. Yeah. Now, good. You have different answers, and I can frankly say that none of the answers is correct. So now, why none of the answers is correct? It is because we consider the longest chain, and the longest chain is this. Now you are saying, so this is the longest chain. Then the rest, sorry, there is a 3 here. The rest will be groups that are attached on the longest chain. Okay, so our longest chain is going to be carbon 1, carbon 2, carbon 3, carbon 4, and then carbon 5. So the longest chain is pentane. Okay, the longest chain is pentane. And then the groups that are attached on the longest chain is this one and this one. And they are all methyl groups. So this one shall be, the one is attached on carbon 2, another one is attached on carbon number 3. So it shall be 2, then comma 3, then dimethyl pentane. So this is going to be the name of our compound. So do you see? So if people, nomenclature, don't take it for granted. The rules of the IUPAC rules, they should be part of you. Okay? They should be part of you. I think I'm going to. Now, after the lesson, somebody should remind me to post work in our classroom for nomenclature. Somebody, please. Somebody should take responsibility and remind me to post work. You can text me via WhatsApp. Yeah, I'll be online. Text me. Or you can remind me immediately after the lesson so that I can post work for nomenclature. Okay? And you name those compounds. So that's how this one is. So let's proceed. I'll post work and you practice enough. Okay? So for example, when you have this, can you name this? Chap chap. But anyway, can you name this chap chap? Chap chap. You don't need to go through a lot. Just chap chap.
Is 2-methyl
butane.
butane.
So it is 2-methyl butane. That was Edwin. 2-methyl butane. And then this one. Now this one you can't name it. You can't name it because of this group. Oh. Now because of this group, you can't name it. Okay? But this group is called isopropyl.
Yes. How are you?
That group.
How are you?
Okay? This group, it is an isopropyl group. You can see this and this attached on the parent chain. So it is named as an isopropyl group. So can you go ahead and name?
It is 3 isopropyl
3
pentane.
isopropyl pentane.
That's good. Good, you all answered at the same time. Yes?
Teacher,
Yes.
the previous one, isn't it 3?
This one, eh? No, we consider the lowest sum. You see, if you count from this side, it
Yeah.
will be 1, 2, 3, and then 4. But if we count from this side, it will be 1, 2. So we give the lowest row count, the lowest position of the group. And the lowest is 2. But now for this one, it is 1, 2, 3, and then 4, and 5. And if count from right to left, it is 1, 2, 3. So still it remains 3. And so that one becomes 3 hyphen isopropyl, then 1, 2, 3, 4, 5 pentane. Okay? Pentane. So it is basically as simple as this. And if do we have any other? 3 isopropyl pentane. So that is basically nomenclature. Somebody please take care, be responsible, and remind me after the lesson to draft some questions for you. Okay? As far as nomenclature is concerned. So let's talk about isomerism. We also talked about this in details. And alkanes do exhibit structure isomerism. Okay? The difference in structure. You have the same molecular formula, but you have different structures. Now nothing like position, nothing like because position, it is the same functional group, but the functional group is varying. Now here the functional group is just carbon. So now which position are you going to consider? And nothing like so it is structure isomerism, and to be specific, chain isomerism. For example, where you have carbon 6H14, it can be any hexane, normal hexane. Okay? C, it can be normal hexane. Or if I get this group and I transfer it and put it here, okay, and I get one hydrogen and put it on this carbon, it remains the same. I form this, okay, and this one is 2. Can you name this? Hurry up, guys, hurry up. You are the ones to do the naming.
It is 2-methyl pentane.
2 methyl 2 methyl pentane. Okay, I hope it is correct. Let me see. 1, 2, 3, 4. Yeah, it is correct. Then similarly, I can get this group, okay, and I transfer it from this carbon atom to this carbon atom, okay, and I get one hydrogen and I replace it with this. So still that one becomes Otim, can you name this?
3-methyl
Yeah, that is 3-methyl
propane.
3-methyl 3-methyl pentane. Not so? So this is 3-methyl pentane. Why pentane? Because there are 5 carbon atoms. Similarly, when this one was here, now with this, I can also bring this, okay, and I put it on this carbon atom here, and then I get one hydrogen and I put it on this carbon atom, okay. So I form 2 methyl groups, this one and this one. Edwin, can you name this? Hurry up.
It is 2,3 dimethyl
2
butane.
2 3 hyphen dimethyl what?
Butane.
Butane. Can you tell those ones to extend? Butane. Similarly, I can transfer this group and I put it on this carbon atom. Okay? And I get this hydrogen and put it here. Or even if I do the same, I transfer this group and I put it here and I get the hydrogen and put it here, it remains the same. And I form this. Otim, can you name this?
2,2.
2,2.
Dimethyl butane.
2,2, yes. Dimethyl butane. Hey, so now do you see how nomenclature is becoming fun? But if you tend to forget the IUPAC rules, then it becomes killer. Okay? So that is basically isomerism. And alkanes do exhibit structural isomerism. Any question as far as isomerism is concerned and nomenclature before we see how they are prepared? Yes.
I've heard you say that we have normal hexane. Can we have abnormal hexane?
Okay, that's an interesting question. So if I write this, C4H10, what comes in your mind is this. This is what comes in your mind. And then the rest are hydrogens. Okay? The rest are hydrogens. So this straight chain of butane, it's a normal butane. Okay? And usually it is written as N-butane. That straight chain, because that's what exactly comes into your mind. Okay? Yes. But it doesn't stop you from having something different. Maybe if I transfer this one from here and I put it here, and then I bring the hydrogen here, and I form this CH3, and then CH, and then CH3 here, okay, and then another CH3. So now, this one is, they have the same, okay, but this one is now 2-methyl, 2-methyl what? 2-methyl what? Nobody's speaking. 2-methyl propane. So this one now becomes a deviation from what we expected. So that's why these ones, the straight chains, are usually named as normal N-butane. Then the branched ones, those are abnormal according to your question. Okay? The branched ones, they are abnormal. So I hope it is okay now. Any other question? Another question? If there are no questions, then let's talk about preparations of, let's see how alkanes are prepared in the laboratory. And by the way, even before we go deep, in organic chemistry, let me give you a magic bullet. Let me give you a cheating code. You know all functional groups? Okay? You know all functional groups? And you know how each functional group is prepared? Okay? How each compound is prepared? Okay? And after knowing how each compound is prepared, you know how each compound reacts, the different reactions of each compound or each functional group, okay, and then you know some physical properties too. So if you know this, organic chemistry becomes easy, because it is this what is examined. We shall say, show how you can synthesis, okay, synthesis. For you to synthesize anything, you must know how it is prepared, and that's how those are preparations. And for all functional groups, we shall talk about preparations. For you to synthesize, you need to know how it is prepared. And then after synthesis, we talk about mechanisms or reaction mechanisms. Okay? And with the reaction mechanisms, you need to know the reactions, different reactions that compound undergoes. And then the physical properties, the chemistry. Why does it have a high melting point than the other one? Why does it have a high boiling point than the other one? Why is this one is a liquid and the other one is a solid at room temp? So those ones, you must be able to explain them. And then some few chemistry. If you know this, then organic chemistry is going to be so easy for you. So let's see how alkanes are produced or are prepared in a laboratory. And it is just simple. We can prepare them from unsaturated hydrocarbons. And we said with unsaturated, these are hydrocarbons with a double, okay, or triple bond within their carbon skeleton. If you have a double bond or a triple bond within your carbon skeleton, then you are referred to as unsaturated organic compound. And so we can prepare these alkanes from unsaturated organic compounds by hydrogenation. So if we hydrogenate, okay, anyway, let me display. I know it is there. If we hydrogenate these organic compounds, okay, these unsaturated hydrocarbons by hydrogenation, then we shall form our alkanes. And how are we going to do it? We shall react our unsaturated organic compound, that is if an alkene or an alkyne, with hydrogen. Where is it? It is here. But this reaction occurs in presence of a catalyst. Okay? It occurs in presence of a catalyst. And there are three catalysts that we can use here. The first one, we can use nickel. The second one, we can use platinum, or you can use palladium, any of the three. The choice is yours. If you decide to use palladium or platinum, then this reaction occurs at room temperature. But if you decide to use nickel, then you must heat up to 150 degrees Celsius. Okay? So the choice is yours. It is up to you to choose what you are going to use. Nickel at 150 degrees Celsius, or platinum or palladium at room temperature. So instead of 150, if you put 200, I'll cross you. If you put 100, I'll cross you. If you don't put anything, I'll cross you. But for platinum, you just put PT and you're done. For palladium, you just write PD and you're done. Let's see. So it will be hydrogen, okay? And the hydrogen is a gas, plus, it's okay. So you have your unsaturated alkene. Maybe, let me say, I'm going to use maybe ethene, okay? And I'll react it with my hydrogen, okay? but the whole of it I can decide to use nickel. But if I use the nickel, then I must heat at 150 degrees Celsius. That is if you've decided to use nickel. Then we shall form our alkane, CH3, CH3. Is that good? Is it good enough? But if you decide to use palladium or platinum, okay, now here it occurs at room temperature. CH2, CH2, and you decide to use platinum. So this is hydrogen, okay, in presence of platinum or palladium. You use one, not both. Now this one occurs at room temperature. You can decide to write room temperature RT, or you can decide to leave it. There is no harm. Okay, so we shall get our alkane, CH3, CH3. So where the hydrogen adds across a double bond or triple bond. Oh, somebody, I don't know what is wrong. Let me first talk to this person and see. It's okay, guys, it's okay. So even with alkynes, okay, let me write it here. CH with a triple bond, and then CH, okay, react with hydrogen, hydrogen in presence of platinum or platinum catalyst or palladium. Then we shall get, now the hydrogen here must be in excess, okay, to replace all those three bonds. Otherwise, if the hydrogen is limited, then you produce a mixture, okay, of alkene, okay, and an alkane, which is not effective. For you want an alkane, but you have some double bonds that have not been replaced. So the hydrogen, therefore, must be in excess. Is it okay to everyone? Any questions for me? Any queries? Seems?
Some more elaboration about this of alkanes.
Pardon?
Some more elaboration about this one of alkanes.
Some elaboration on alkynes. It is the same thing. A triple bond or a double bond. Okay? The hydrogen will add itself across a triple bond or a double bond. So now, because here you have the three bonds, then the hydrogen, it will add across here, you form an alkene, but because hydrogen is in excess, then it also adds across the double bond that has been formed to form an alkane, a single bond. So it is basically the same. There is nothing different here. Is that okay?
Yes.
Okay, that's brilliant. That is pretty good. So let's proceed to another method of preparing alkanes. I think I have an equation here and it is the same thing. So that's basically how we can prepare alkanes from alkenes and alkynes. Now, the second method of preparing alkanes is we can prepare them from halogeno alkanes or alkyl halides. Now, what are, halogens? It could be bromine, it is chlorine, it is hydrogen, it is iodine. So these are the most common halogens that we shall find in organic chemistry. For fluorine, it is too reactive, too electronegative, that will tend to form unstable organic compounds which do not exist. So for these are halogens, but the halogen, it is halogenoalkane. The halogen is bonded an alkyl group, and alkyl group, it could be a methyl group, CH3, it could be an ethyl group, CH3, CH2, okay. It could be a propyl group, CH3, CH2, and then CH2, and so on and so on. So as long as this alkyl group is bonded to a halogen, maybe you might have a Br here, maybe you might have a Cl here, maybe you might have an iodine here, and so on. Then this one is called an alkyl halide, or a halogen alkane. And so we can prepare alkanes from these alkyl halides. Okay? We can prepare alkanes from alkyl halides. And there are different methods that we can employ here. Okay? There are different methods that we can employ here. And the first one is using zinc in presence of conc sulfuric acid. Conc hydrochloric acid. So we can take away that halogen atom using zinc. But however, it occurs in presence of conc HCl. Then we shall form an alkane. And you can check on it. So you have your zinc, so you have your alkyl halide, and you react it with zinc in presence of conc HCl. Okay, then we shall form our alkane, and then the zinc takes away the chlorine and you form zinc chloride. And the same happens for bromide, the same for iodide. Okay, yes, so that is method 1 of preparation of alkyl halides the preparation of alkanes from alkyl halides. Can you do this? Anyway, it is there. Can you name this? What is this?
Cyclohexane.
Yeah, that is cyclohexane. Cyclohexane. Yeah, basically that is as simple as that. So we can also prepare alkanes from alkyl halides using the Wurtz reaction. And like I told you, this is the reaction that I like most as far as this is concerned. I really like this reaction. It amazes me. It is interesting. It's good. How good? You're going to see and you're going to like it. So when you get your alkyl halide, okay, and you heat it with sodium metal, okay, in presence of a dry ether, okay, and in this case we are going to use diethyl ether, presence of a dry ether, then an alkane is formed. However, this is why I like it. This was a reaction. You heat your alkyl halide, okay, with sodium metal in presence of a dry ether, then an alkane is formed. However, this is why I like it. The alkane formed is going to double in the carbon chain. For example, if I have this CH3 Cl, okay, oh my god, sorry for this, and I heat it, with sodium metal, okay, in presence of dry ether, okay, then I shall form an alkane. However, the number of carbon atom is going to double, okay, so that I form CH3 and then CH3. Is this hard? Plus the sodium bromide. But for us in organic chemistry, we are always interested. No, sodium chloride. Sodium chloride. We are always interested in the organic part. Is that hard? Let's say if you have this, if you have this CH3, CH2, and then Br, and then you react it with sodium, sodium in presence of dry ether. Can you please name the product? What is the product? Please unmute and name the product.
Butane.
Somebody saying butane. CH3, CH, CH2, but it is doubling in the carbon chain. And then CH2, and finally CH3. And this one is butane. If you want, you can say N-butane. Are you enjoying the chemistry? Do you see why I like this reaction? I enjoy this reaction like nothing else. Guess what will be the product here? CH3, CH2, and then CH, and then you have the CH3 here, okay, and then CHBr, and then I heat it with sodium in presence of dry ether. Now, write and name. Write and name.
No,
So
first it is 1 4
let me write.
dimethylhexane.
Let me write it here. 1 4
Dimethylhexane. 3 4
dimethyl
hexane.
hexane.
It is 3 4.
3 4. Okay. Edwin, what is yours? Oh, I wasn't recording. So this is Edwin's for him. He wrote and he didn't name. So can you please name your work?
It is a C4 dimethyl hexane.
3 4. In other words, the same as this, eh?
Yeah.
Okay, now I see you are smart guys. You are smart guys. Okay? This is very good work. So everything this side doubles. Okay? Everything doubles. And you form such a compound. Let's name this. Let's name this. I might give you this. And then there is this, and then Br. I don't want to talk about benzene. Okay, let me call it benzene. However, in the naming it is going to be hard. And then sodium in presence of dry ether. So what do you form? Don't mind about the naming.
we form two benzenes added together,
We form two benzenes added together.
and then and two groups added on the opposite side.
Huh? I think I'm going to be insinuated to have a look at your structure. I'm going to be insinuated to have a look at your structure here. Even on team? Actually, let me go and have a look at your structure. Okay, so this is it. And some heating, of course. Sorry for that. So, from this, it doubles. And it doubles from where? I've seen your structure, but yeah. So it doubles. And the doubling is from where the halogen is attached from. So everything this side doubles. Okay? And so we shall form CH. So everything doubles. And it's like this, you see, CH2. So now from here, everything doubles. So we shall have another CH2. Okay? And then the benzene, the ring. So everything that side doubles. Okay? So, and it is as simple as that. Really? So that's how. That is what gave you a bloody nose. And when you are naming, you want us to name this? Now, if you are naming, this one becomes the parent chain. However, the nomenclature is going to confuse you. But let's name so that you get exposed to it. So this one becomes our parent chain. Then these ones, they are groups that are attached on the parent chain. And one group is attached on carbon 1, another group is attached on carbon number 2. So it becomes 1, 2 diphenyl diphenyl, then this is ethane, diphenyl ethane. So why am I giving you these reactions? It's in the case of any question, because questions, they can twist questions. So I can give you this when I just want you to recall this reaction, the Wurtz reaction. It is called Wurtz reaction because it is this guy who discovered it. Okay? So I can give you this when I want you to use the Wurtz reaction to get the product, and the product is going to be that one. Okay? Yes. Now don't ask me about the name. But anyway, you can. It's okay. So it is diphenyl. Why? Because there are two benzene rings, and the benzene rings are named as phenyl. Okay? And the rings, the groups are attached on carbon 1 and carbon 2. So that's why it becomes 1,2 diphenyl ethane. Basically, it is as simple as that. Is that okay, everyone? Yes. So let's have a look. This one, CH3. Now there is something missing here. This is wrong. So on carbon 2, we have a methyl group. So even this side on carbon 2, there must be a methyl group. So this is CH3. CH3. And so when you are naming, this one becomes 2,5. Okay? 2,5, and it is 2 stroke 5 hyphen dimethyl. Okay? Dimethyl. I thought I wanted to change this, but I forgot. Then dimethyl. Is it 5? 1, 2, 3, 4, 5. Yeah, it's 5. Then dimethyl hexane. So it is as simple as that. Why am I even saying pentane? So this was just a mistake. Okay, this was just a mistake. So I hope everything is okay now. I hope whose reaction is okay. Hey, it is even time. So maybe we can call it